Hi. So we're going to move on to the next topic with all of this factoring. And to start, I want to actually double distribute x plus 3 times x minus 3. If we do our double distribution on that, we get x squared minus 3x plus 3x minus 9. Just like we've always seen before, the middle two terms will go together, but this time they actually add to 0, which means that this is left with x squared minus 9, which if you take a look at this is very different than what we've seen before because it's a binomial with only two terms, whereas all the other things we had done before were trinomials with three unlike terms. Why do you think that happened? Let's try a couple of more to see if we can figure it out. So if I had y minus 10 times y plus 10, and I do my double distribution, that would be y squared plus 10y minus 10y minus 100. And again, if I look at those middle terms, they go to 0, so this leaves me with just y squared minus 100. And again, we've got a binomial instead of a trinomial. Alright, so I would like you to try a few more of those, please. So I'll write down 3 of them, and then you can do your double distribution and see what they come up with. So if I have a plus 4 and a minus 4, and then 2x plus 9 and 2x minus 9 and 7x minus 5 and 7x plus 5. So do your double distribution and see what those come out to be. Pause the video and try that. So for the first one, I got a squared minus 16. For the second one, I got 4x squared minus 81. And for the third one, I got 49x squared minus 25. So if I look carefully at all those things, they ended up being binomials. And I'd asked earlier why. Why do you think that is? There was a special thing that we should have seen back in the original binomials that we were multiplying together. If you notice, these two things, these two factors are exactly the same, except one of them is a minus and one of them is a plus. So that when we ended up doing our double distribution, there were always two middle terms that were exact opposites of each other, additive inverses, meaning that they go to 0 when we add them. So we're going to use that idea to move backwards now. If I was to start you with something that looks like, let's see, x squared minus 49. So if we see, all of these things kind of ended up looking a particular way. First, notice that all of them have minus signs in them, because when we did our double distribution, a positive times a negative ended up being a negative. Okay, also notice that all of these things that are left are perfect squares. X squared is a perfect square, it's x times x. 9 is a perfect square, it's 3 times 3. Y squared is a perfect square, it's y times y. 100 is a perfect square of 10 times 10. A times a, 4 times 4. This is a perfect square of 2x times 2x, that's 9 times 9. 7x times 7x, 5 times 5. So I'm going to use that idea, and first off, I'm going to actually name this thing. This thing right here is called the difference, meaning subtract, of perfect squares. In particular, two perfect squares. So this is what we're doing today. We're factoring using the difference of perfect squares. Okay? So if I notice that I have two perfect squares that are being subtracted from each other, the factoring is actually quite simple. I know that if I factor, unless it's a GCF, I'm going to look at it like this. And now, all I have to realize is that this was the result of multiplying two polynomials that were exactly the same, but one being positive and one being negative. The only way to get x squared is x times x, and then 49 is 7 and 7. Make one of these positive and one of these negative. That is the factored form of that binomial. Okay? This is the difference of perfect squares. So the most difficult part about this a lot of times is recognizing it. Okay, so if I gave you 4x squared minus 81, I need to recognize that 4x squared is a perfect square, 81 is a perfect square, and these two things are being subtracted. Since that's the case, I'm going to factor this using the difference of perfect squares method. This had to come from multiplying two binomials that were the same but opposite. So the square root of 4x squared is 2x and 2x. The square root of 81 is 9, so it's 9 times 9. One of these is positive and one is negative. Remembering, of course, that it does not matter where they go because order doesn't matter when you multiply. Okay? That's what this is. So, if I was to give you x squared minus 121. Okay, again, perfect squares, difference. So this is going to be x and x. This is going to be square root of 121 is 11. One positive, one negative. Doesn't matter which. One that tends to confuse students a lot is actually y squared minus 1. That is the difference of perfect squares. What times itself is 1? You got it, it's 1. So this is the difference of perfect squares. It's going to look like this, where the way to get y squared is y times y. This is 1 and 1, but one's positive and one's negative. And by the way, if you weren't 100% sure why this is the case, try doing your double distribution. I bet it's going to work out, but you might want to prove it to yourself. Okay? How about something like 9x squared minus 49y squared? Does that still look like the difference of perfect squares? Well, in order to answer that question, is it difference? Yes, because I see a subtraction sign. Are both of the terms perfect squares? Well, 9x squared is 3x times 3x. 49y squared is 7y times 7y. It is the difference of perfect squares. So this will look like this. To get 9x squared, we do 3x times 3x. To get 49y squared, we're going to have 7y times 7y, but one is positive and one is negative. That's it. Okay. Try a few more, and then will be it for this. So how about 2x plus 3 times 2x minus 3? What will that give you? Okay, and then using that idea, what if I were to give you 9n squared minus 49? Factor that. This is a double distribution. This is a factoring by difference of perfect squares. How about 16c squared minus 25? Factor that. And then how about 4x squared minus 1? Okay, try those, pause it, and come on back. Alright, here I got 4x squared minus 9. So if I recognize the similarities between these, again, I see this is the difference of perfect squares, so I should have 3n plus 7 and 3n minus 7. This I also recognize as the difference of perfect squares. It would be 4c plus 5, 4c minus 5. This is the difference of perfect squares, which is 2x plus 1 and 2x minus 1. Okay? It really should be that simple. Of course, there are some little things that you have to look at. For instance, if I were to give you x to the fourth minus y to the fourth, ask yourself if those are perfect squares. Does something times itself equal x to the fourth? And the answer to that is yes. And y to the fourth also is equal to something times itself. What times itself is x to the fourth? Well, that would be x squared times x squared. And then what times itself is y to the fourth is y squared times y squared. That would be a plus and a minus. And again, prove it. Double distribute this. Make sure you do, in fact, get that binomial. Okay? So, I am going to do 3 more. I'm going to give you 3 more to come to class with. Okay? How about x squared minus 16y squared? And let's see. We'll do a simple one, x squared minus 144. And 4a squared minus 81b squared. Have those ready when you come to class on Thursday. If you have any questions, please make sure you write them down. Be ready to ask when you come to class. See you later.